Can you just open your timer? Did you see the timer? No. You see no. The Nico also have timer. You see, yeah. You see the but
I can do this in 5 minutes, man. Okay.
you need to explain to me and okay.
Okay.
1 second. Let me talk about and I will tell you. You can start the timer.
Are you recording or not?
Yeah, I will record it.
Okay, hurry up.
Okay, now you have 14 minutes to finish this question, and if you have any questions, just let me know. Okay, you can start this question.
Okay, today we're solving week number 53 called maximum subarray. So we're pretty simple question. We're given an integer array called nums, and we want to find the largest subarray with the largest sum, and then just return that sum when you add it all together. So the key here is subarray. What does that mean? Well, subarray means it has to be contiguous, right? So -2, 1, and -3 together are subarrays. -2 and -3 is not a subarray because there's a digit in between. So it has to be contiguous. So how do we do this? Well, this is getting a bit tricky because we have to account for the fact that we have negative numbers and the fact that any negative number plus any negative number is always going to be smaller than that negative number. So it's like we might as well not even use that other negative number, right? So because we want to look for the largest subarray sum. So this is going to really come in handy. And obviously, we can't sort the array because we have to use the order they're given in. And that's sort of the tricky part about it. Obviously, you have some base cases here where there's just one element. Obviously, it's just that one element. So for example, if we had an input like this, obviously the output would be -8 because there's only one element, and the largest subarray we can find from the input is -8. So again, the constraints are here, and what we're going to do in this problem is use Cadane's algorithm. So how we do that is we iterate through the array, and we look at the number, we add it to our subarray sum, and we say, is the subarray sum less than 0? If it is, then this guy's never going to contribute to the largest subarray sum. So we can just discard it, reset it to 0, and keep looping, and say 1, because -2 plus 1 is less than just 1 by itself. And so if this is our input, then the output would only be 1 by itself. And we keep doing this as we go through the array. So we are going to initialize a result variable and set it to nums of 0. You can also use nums of -1. It doesn't really matter because the algorithm will be computing the maximum subarray sum. You can pick any number, but it has to be some number in the array. So we're going to initialize a variable called subarray sum, initially 0, because again, we haven't added any elements in there yet. And then we're going to loop through our input array. So for number in nums, and we're going to ask the question, is subarray sum less than 0? It's never going to be true on the first turn because subarray sum is equal to 0. But in future turns, if the entire subarray sum, this is important, is less than 0, then we set it back to 0 to neutralize it because of the reasons I just explained. And then we can add the current element to number, and then we can calculate the maximum between the result, which is first element, and then the subarray sum so far. So let's say subarray sum, you might ask, why are we putting this conditional here? Well, okay, let's say that subarray sum initially here was 2, and then after we add it, subarray sum is -1. Well, result is never going to be negative, right? So because we're finding the max, let's say result is 1, then we're still finding the max of this, which is still 1. So the negative doesn't even count. And then on the next iteration, when we go to the next digit in the input array, then we're going to hit this if condition and neutralize it before adding the next number again. And we're going to go through the entire array and do this. And at the end, result is going to have the maximum subarray sum. And the time complexity of this, I think, is O of n because we're only looping through the array one time. And as you can see, it passes all the test cases. But also one more thing to mention is that if you were to approach this question with a sliding window approach, the reason it doesn't work is because, first of all, the numbers are not sorted, and second of all, you have to use their ordering. And because of that, sliding window doesn't really work because we would have to keep track of what makes the window bigger. And just because you shrink one element from the beginning of the window doesn't mean that it's going to be bigger or smaller because, again, the numbers are in random order. So just one thing to mention there. So let's submit it.
Okay.
And there you go.
But
so,
you mentioned
algorithm.
So you mentioned a slide window cannot solve this problem, right?
Yes.
Okay. But you are
So,
using.
like, for example, let's take this first example, right?
Mm-hmm.
If we were to use a sliding window approach, because a lot of the mistake I made before is it sounds like a sliding window because you say, okay, just to keep expanding, then calculate the subarray sum. That's not the case. So first window is -2. Next window is -2 plus 1 equals to -1. Right?
Mm-hmm.
The maximum subarray sum at this point is 1, not -1. And then you might say, okay, well, fine. -1, let's shrink the window. Let's kick this guy out. But, just because we're kicking the -2 out doesn't necessarily mean that we're getting the largest subarray sum, because what if this guy is positive? So, cool, now you're getting 1, but then we're expanding the window again, and we're getting -2, but then let's expand the window further. -2 plus 4 equals to 2, and then -1. We're going to add this. So -2 plus -1 is -3. Cool. But just because we are removing, well, if we only had negatives throughout the entire subarray, then the sliding window wouldn't even work because, again, for the reasons I mentioned, you don't know what the number is, positive or negative, and the sliding window operates on a model where we're just expanding and shrinking the window, and that's not enough to determine this. We need a better way to do this. So this is the way to do it.
Okay. So you mean the approach is dynamic programming, right?
No, this is called Kadane's algorithm.
Okay. Okay. Sound good.
Yep. So a lot of edge cases with this problem. So yep. So for example, if we were to actually implement a sliding window, you would fail a bunch of edge cases. So, and I mean, if this was in sorted order, then you could use the sliding window, I think.
No, so why you can the slide window only in the binary search need to be make sure the array is sorted, right? Binary search. But slide
Well,
window.
how would sliding window find the maximum subarray? You can't, because you have to use their ordering. Just because you get, okay, sliding window, you can only shrink the window from the rear and expand from the front, right?
Yeah.
That's not enough options if you have an array like -1, -1, -2.
Mm-hmm.
Okay, the result is supposed to be -1, but if you just slide the window and then you just keep shrinking the window, you're not going to get -1, or you might, but I don't think it's as efficient, and there's still some edge cases in there that you would fail, I think. So.
So, okay. But I would say in this question,
I mean, if you can solve this with a sliding window, that'd be great, but I don't think you can.
You don't need to sort it, right? In this question, did you sort it?
You cannot sort it because you have to use their ordering.
Yeah,
you
ordering,
can't
right?
say, okay, like the largest subarray, let me just sort it. 1, 2, 4. Okay, then it's going to be 7. No, you have to use their ordering. The reason it's 6 is because this is the largest subarray. 4 minus 1 is 3. 3 plus 2 is 5. 5 plus 1 is 6. This is a contiguous subarray.
Mm-hmm. It's continuous subarray, right? Continuous.
Contiguous. This is
yeah.
Is 4 plus 2 plus 1 is a valid subarray? No, that's not, because you need to include this guy as well.
Yeah, so it's window, right? Why it's not window?
Because of the negative numbers. So let's try sliding window, for example, and you'll see. So, okay, let's start the window. Let's say both are here.
Mm-hmm.
and you want to find the maximum of nums. Well, num 0, maximum nums. You can use max nums too, it doesn't matter, but the algorithm should calculate that. Okay, so maybe let's say if nums of window n is bigger than 0, then we can keep expanding the window. And if it's not, then we shrink the window.
Yeah. If you find out the subarray sound is less than 0, right? You mean you need to narrow the window, right?
Yeah.
Yeah. So that's why it's still window, right? Why this one is
But
not?
for example, if you keep expanding here,
Yeah,
you're going to get this whole thing. You can't just get this. How would you get this portion with sliding window? You go, okay, expand, shrink, expand, but then you have to shrink. So this guy is the biggest subarray out of these three.
Yeah,
we don't even need these two guys.
Yeah, we're changing
you
the
see
window,
what I'm
right?
saying?
So
how would you get this with the sliding window? Would you keep expanding? If you keep expanding it here, then how would you know to shrink then, right?
Mm-hmm.
That's the confusing part. That's why you needed, I think Kadane's algorithm is what this question is testing.
So
unless there's a way to do it with the sliding window, which I don't think.
Dynamic programming. Okay.
Or maybe there is. I don't know. There might be a way with sliding window, but I just think Kadane's
dynamic programming question.
Yeah, you can do it a lot of different ways, but this is the way I was taught to do it.
Yeah, I think it's good. It's good explanation, and I think other people. Oh, okay.
Yeah.
So I just started.
Yeah, I think this is a really good explanation because I mentioned all the edge cases and what to look out for. Yeah.
Okay, then I just start recording.